Hey everyone, it's your host Dave Baggett, founder and CEO of INKY, and welcome to another exciting episode of Phish Friday. Happy Friday, everyone. Today we're going to do a little bit different thing, and I'm going to go through a presentation on account takeover and specifically how at INKY we block account takeover attempts using Stylometry. And I'll explain what Stylometry is, and I'll talk about how it works, and I'll give you some intuition about how we use machine learning to identify these nasty account takeover attacks. So first, let's look at the problem. We know, obviously, account takeover is a problem, and you probably wouldn't be listening to this video and watching it if you didn't already realize this, but just to sort of quantify it, we're talking about a lot of these account takeovers get past the incumbent seg systems. That's partly because these are really hard to detect, and it's partly because the attackers who send them understand very well how the seg systems work, and they use techniques to evade them. They're usually impersonations. So usually an account takeover pretends to be a brand or pretends to be a person. In some cases, it impersonates the person whose account was taken over, and that's really difficult to detect. We'll talk about that. And I like to distinguish third-party account takeover from first-party account takeover, because really the best practice to deal with account takeover differs based on the type of account it is. So if it's your own account, which I call first party account takeover, if it's your own accounts, you shouldn't be using a system to detect those takeovers after the fact. You really should be using multi-factor auth, two-factor auth, whatever you want to call it, to prevent the accounts from getting taken over in the first place. So you probably know, but with multi-factor authentication, your accounts are not simply secured by a password, they're also secured by a second factor, ideally an authenticator app like the Microsoft Authenticator, but it could be an SMS to your phone. You want to secure your own accounts using multi-factor auth so they don't get taken over, because if they're taken over, that's bad for you, and it's also bad for the entire ecosystem, because then you become a third-party account takeover scenario that's used to phish other people. And finally, the losses involved in this, we're seeing a lot of wire fraud, obviously, but now we're also seeing account takeover emails that try to engage the recipient in going and buying gift cards and other proxies for stealing money. And this is just creating an incredible dollar amount of loss for US companies. So again, first party ATO for us, we define it as your own employees' accounts, your own users' accounts. Again, protect those using multi-factor auth. And remember, securing an account with just a password is just an inherently bad idea. Even if the password is strong, you'd be surprised how readily attackers can run offline dictionary attacks and brute force even passwords that you think intuitively are strong. And finally, password reset is a huge hole, especially since it's almost always done through email. There was a famous case with Marissa Meyer's account getting taken over on Yahoo because she had the password security question set to something that was public information. People can use social media information about your employees to figure out what their security question answers are and reset their passwords. So secure your own accounts with multi-factor auth and protect your own first-party accounts from getting taken over. For third-party account takeover, it's a real problem because you can't make all of your counterparties implement proper security protocols. So if with email, you can email anybody in the world. We can't ensure that everybody in the world we're emailing has themselves implemented multi-factor authentication. So really the only way that you're going to tell that you've got an account takeover on a third-party account is, as that mail comes in from that taken over account, you've got to detect it. And we use machine learning techniques to detect these, and the method involves something called stylometry. So I'm going to first describe what this stylometry area is. This was developed arguably in the early 1900s, but really took off in the 1960s with the advent of computers. And the concept was, we've got documents that we don't know who authored them, and we might believe, for example, that this play Double Falsehood was written by Shakespeare. We don't know, though. So the idea was that researchers came up with in the 60s was the idea that, well, let's compute a bunch of metrics of the text, the way it's punctuated and spelled and the vocabulary usage, and we'll compute those metrics for a bunch of documents that are known to have been written by certain people or an author. And then we can compare the candidate manuscript that we're trying to determine authorship of the metrics from that document to the metrics from the corpus that we've computed. And so this has been used to validate Shakespeare plays, determine the authorship of the Federalist Papers, and so on. So in essence, we're using this same kind of mechanism for email. And it's worth pointing out, there's a lot of really interesting stuff you can figure out from surprisingly small clues in electronic communication. So for example, there's a few papers on the idea of determining the gender of a sender by looking at their use of emojis. So if you look at the left and the right, the left was sent by a male sender, the right was sent by a female sender. It's kind of surprising, but there is enough information even in the use of emojis to tell, statistically speaking, the gender of the sender. So think about doing the same thing for emails. Well, there's all kinds of clues in the emails. Obviously, emojis might be in there too, but there are all kinds of clues in there that tell us things about the behavior of the sender. And so in essence, this, for example, is a ranking of emoji usage by men versus women. You can see there's a stark difference, and this therefore is predictive. So in the same way, we find what we call features that we can extract from the emails, either the headers of the emails or the body, what the text that was written of the emails, that are also predictive. But in this case, we're not predicting gender, we're predicting, is this mail written by this person? And our corpus is a set of mails that we've collected for that person before. So as INKY scans each mail as it comes in, it's looking to find signs of malicious intent. It's also computing these metrics and associating those metrics with the machine learning model that's stored for each sender. And then when a new mail comes in, we wonder, is that actually written by the author, the purported author? We can compare the metrics of that new mail to the stored model. And so you can think of the features as different from emojis, but they're kind of related in some ways. Intuitively, you've got things like punctuation. Do I use a semicolon in my email? Well, that might be indicative of my behavior versus somebody else's. What about the vocabulary I use? Do I use lots of rare big words? So we in fact have a database of all the terms in English and their frequency, so we can compute a metric over the text, which essentially is like the reading grade level of the text. Formatting and things like that, what mail client did they use and how did they format it? Signature and closing, obviously those are things that people often use. Sometimes people will have an image signature block. All of those things can be indicative of the sender. And then finally, even things that are called natural language processing, like the sentence structure, morphological complexity, that refers to, the complexity of the individual words, how many parts of the words are there, and then uses of unusual phrases. And to some extent, some of this has been done since the 90s. For example, all the SEGs use Bayesian models that learn statistical properties of emails and associate them with either spam or not spam, as the case may be. And so they're picking up on some of these things, and will learn things like, if there's lots of dollar signs in the subject line, it probably is spam. So this is kind of using similar features, but applying them in a different way, using something we call clustering. Now, clustering is, if you haven't heard about this is a very well understood, very, very well known machine learning technique. And I'll give you some intuition about how this works using the example of learning to recognize handwritten digits. You're going to say, what does this have to do with email? I'll explain in a minute. But imagine that you're given the task of make the computer recognize from an image of a handwritten digit, which digit is it? You could see there are lots of zeros on that first line, there's lots of ones on the second line, and they obviously are different from each other. They don't match identically, but they have some sort of 0 or 1 or 2 character to them. So the concept is, can we learn something, have the machine learn something using statistics that will tell it, hey, that's likely to be a 0 digit, that's likely to be a 1, and so on. And this is what a classic problem that's solved using clustering. And the way you can think about this is, if you look at this page here, you've got the light sort of sky blue squares, you've got the dark blue squares and the red squares. Think of each of those as a cluster. So each of those squares corresponds to an image of a digit on the left. And the ones that are all clustered together at the top, maybe those are the zeros. And the ones that are clustered in the middle, maybe those are ones. The fundamental intuitive concept here is that by picking features that accord with our human intuition about similarity of the things we're trying to compare, in this case, digits, by picking those carefully, we can create essentially what's called a distance metric and map every example input, in this case, every handwritten digit image, in a high dimensional space. And just magically, it seems, if you pick the features right, the digits that are similar to each other, in other words, all the zeros, will cluster together in that space. So they will be essentially near each other and far away from the other digits. So you can think of, again, those sky blue ones, maybe those are the zeros, the dark blue ones are ones, and the reds are, one of the other digits. This is the concept of clustering. Now, obviously, we're doing this with emails and not digits, and I'll explain what that means. But just to give you a little more sense of what we're talking about here, here's a way to visualize clustering in 2 dimensions. So we talked about a high dimensional space, and obviously it's really hard for people to think in terms of high dimensional spaces. We're sort of 3-dimensional creatures. So let's start thinking about this conceptually as a 2-dimensional space. Imagine that we extracted 2 features from the digits, and we plotted each digit as a point in a graph that had an X and a Y axis. So you might think all the ones might end up in that yellow region, the 7s might end up in that blue region, and the 4s end up in that red region. But notice you've got a couple borderline cases, like that one at the top kind of looks like a 1 and a 7. So we would expect that would be close to both the 1 cluster and the 7 cluster, just conceptually. And similarly, that other one there kind of looks like it could be a 4 or a 1 or a 7. That might be right in the middle of all 3 of the clusters. And so the idea is, again, setting up your distance metric, the way you decide where these things fall, your example inputs, where do those points fall in space? That's critically important. And if you do it right, it matches up with our human intuition of similarity, this notion of similarity, and similar things then cluster together in this high dimensional space. And the reason that it's a high dimensional space, and here I'll show you a 3D representation. So now we can look at it in 3 dimensions. This is the same data, but this is a Google visualization. The problem with visualizing this stuff is that we don't just have 3 features, we have like 50 or 1,000. And so instead of plotting these points in a 3-dimensional space like this, we're actually mathematically plotting them in a 1,000-dimensional space. And it's incredibly difficult to even envision what that is. But you can think of it as similar, and just as you can see there, the way things naturally cluster together, if you pick the features correctly, as I said, that will lead to this kind of natural clustering in that high dimensional space. So essentially now that's what we're doing for emails, except that remember, we're taking those stylometric features that I mentioned earlier, extracting them, and those are our dimensions of our high dimensional space, and we're clustering, and the points in our space that we're comparing are not images of digits, they're emails. So here's a few real world examples that we've caught of account takeover that will hopefully give you some intuition about how this works and how useful it is. This is a really common kind of brand impersonation. It's impersonating Microsoft. I'm sure virtually everyone here has seen something like this. This is a pretty poor use of an account takeover because it's imitating a brand coming from a university account. It's pretty straightforward for a system like ours to tell, Microsoft Mail doesn't come from Oxford University. But this is indicative of a lot of this kind of thing where universities have either, in this case, an SMTP server that was just an open relay that could be abused by the attacker, or I think more commonly, just students have poor passwords and people guess them and they don't have multi-factor auth set up for students. So a lot of these university accounts are used to send, they're taken over by attackers and used to send things like this. Now, obviously, if you've seen any of our talks before, at INKY, we're going to render a mail like this, and we're going to do brand analysis. We're going to look at the imagery and the text in the mail, and we're going to come to the conclusion. INKY's going to say, hey, this looks like it's from Microsoft, and it's going to know, well, this Oxford University is not a legitimate sender of Microsoft mail, so this is an impersonation. This is a forgery. So we would be able to detect this almost from first principles as a brand forgery, regardless of whether it came over an account, a taken over account or otherwise. Notice too, they're now adding their own green banner. You probably have seen our yellow and red and gray banners. This is an attempt, I guess, for the attacker to convince you that, well, this is a good mail because it's got a green banner on it. Here's a more interesting one. This one is a classic CEO impersonation. someone took over this person's account and sent a mail as me to one of my employees. And this kind of shows you a few things that we can extract from the mail that might tell us, hey, it's not really Dave. For example, that's not my real email address. But even beyond that, maybe I have that as an email address. I've just never used it before. This was sent from Kazakhstan. I've never sent mail from Kazakhstan before. And you can imagine there are things in the headers of the mail that capture, where in the world the mail was sent from and what mail infrastructure was used. Also, this tagline at the bottom, that's pretty indicative. Now, even if I send something from my mobile device, that's not what the tagline says. So you can start to get a picture in your mind of, what are the things that we could look at that would characterize or fingerprint a particular sender. And these are the kinds of things that we're looking at in the headers. In Stylometry, the case of Stylometry, we're more looking at, again, we talked about punctuation. So this example was reported by one of our users. INKY flagged it as a potential sender forgery, and indeed, the user reported it to us and told us, oh, this is my friend Nancy. Her name actually is Nancy, but I redacted her last name, and her account's been taken over 4 times. This keeps happening, and I know this isn't her, obviously. So it's worth thinking, just philosophically, how would you possibly know this isn't the real Nancy? Well, it might have been sent from an unusual Office 365 tenant that Nancy never uses, like Kazakhstan or something. That could be, there could be traces like that in the headers. But I think more realistically, we're going to have to rely, again, on stylometric indications from the text of the mail. So is this something she would write? And so to answer that question, again, we use a clustering approach where INKY's seen maybe 25 examples of Nancy's mail in the past. So INKY now has a model, essentially has extracted metrics from that corpus. The corpus in this case is not Shakespeare manuscripts, but mails from Nancy. INKY will have extracted the metrics from those, and we'll now have a sense of where those mails, those historic mails, would be plotted in this high-dimensional space. And now INKY can say, well, this new one that purports to be from her, I'm going to compute all those metrics, and I'm going to plot this mail in that space. Is it near in that space to mails from Nancy? In other words, is it similar? And again, this math is all simply to capture that human notion of similarity. And the art of doing this is really figuring out what are the features that you can extract, first of all, efficiently and quickly, because we want to process each mail in a second or two, not minutes, but also ones that accord with the human intuition about similarity. So for example, in this case, does Nancy ever use this kind of strange punctuation? That's multiple ellipses in a row. That's a feature you could imagine extracting for every mail's punctuation. Does she use this closing? Is that a typical closing? Does she use a greeting? Now, I don't know the answer because I haven't seen her historical mail. We don't store the historical mails, but the model has been trained on her historical mails. So the model incorporates information about these things. And so we can take a candidate example mail like this that is from Nancy's real account, right? Because remember, we're talking account takeover here, a mail that's actually sent from her legitimate account, but by someone else, and detect that it's someone else and not her based on aspects of what that person wrote. Now, again, sometimes what that person wrote might just be really scammy looking. It might, for example, say, go buy gift cards for me. And that's the way that other systems can detect these in some cases. But a more foolproof way is, again, to model the aspects of the things that she sent before and have a metric to compare. Well, does this seem like the kind of mail she would send? So again, this gives us a formal mathematical way to talk about things like, well, does it seem like something that Nancy would have sent? And again, we're talking punctuation features, word choice features, even things like, well, does Nancy use British spelling or American spelling? Those are all of these things you can imagine that are potentially indicative. And what's interesting is a different set of those may be indicative for a given sender than for another sender. So the trick of this is to figure out what's a set of these features that, again, can be computed quickly and efficiently, but also will capture all the different kinds of behaviors that users have that we can use to fingerprint their mail and tell, does this seem like something Nancy would have sent? Now, furthermore, it's useful to have this yellow banner here, because the yellow banner allows us to say, look, we're not sure this isn't Nancy. We don't know that this is necessarily malicious, but it sure doesn't look like something she would send. Now, there are cases where INKY's completely convinced the mail's not from the purported sender, knows it's an account takeover, and will move it straight to quarantine. Now, in our system, that can be a red banner that goes on the mail. And actually, our customers can decide, do they want the red banner mail to get delivered at all, or do they want to have it go straight to quarantine? Because as you've probably learned from earlier episodes of this, if you've watched them, we run inline in the mail flow pre-delivery, so we don't even have to allow the mail to get delivered. Like a SAG, we can just send the mail straight to the quarantine. But this yellow banner, this gives us a middle ground to say, look, end user, we can't prove this is malicious, but it sure looks unusual. And our admins, admins in our customer base, they can decide, well, what happens with the yellow mail? Does it have links disabled and so on? And all of this stuff is then tracked in our overall database. So admins can go in and see, exactly who's being targeted, what kinds of accounts are being taken over, where they're coming from. This is how, for example, we've learned lots and lots and lots of university accounts are currently being used to just mass send phishing emails to victims in our network. And here's another example of the same kind of thing. Notice I said earlier you might look for style changes. Notice how the font changes there between the first and the second line. Maybe Larry does that all the time, in which case that wouldn't particularly stand out or make this mail different from his norm. But if he's always consistent in the way he uses fonts, this might stand out as an outlier. Also, there's really basic things in here that are trivial to extract, obviously, like it's to and from the same person. It has a sense of urgency. One thing we can do is use a natural language processing to do what's called sentiment analysis. You can run the text of a mail through a machine learning model that's trained to learn, is this angry? Is it positive? Is it happy? And so we can run this through a filter that says, does this seem like it has an element of urgency? Because obviously a lot of these account takeover mails, there's a call to action. They want the victim to do something for them, and they want to make that seem urgent so the user doesn't think too hard before they go and rush off and do it. Another thing that's worth pointing out here as a public service announcement of sorts, whatever your users put on social media, whatever they put in their vacation autorespond mail, attackers can and will use that information to impersonate those people. So now imagine getting this mail from a taken over account pretending to be Larry, and imagine the attacker's actually done the work to figure out, oh, Larry said on Facebook that he's going to be in the Caribbean. Then the attacker, if this is a real targeted spear phishing campaign, the attacker can reference that in their fake mail from their taken over account and make it even more difficult for the recipient to judge this as not being from that person. It's going to sound totally plausible if they say, here I am in St. John, so I can't do this. Can you do it for me? So it's really important to understand and limit what people are saying, particularly about their current whereabouts, vacation plans and things like that. And that's one reason why we tell people, yeah, you probably don't want to have a vacation autoresponder note at all. And if you do, it should just say very generically, I can't answer you right now. Again, these things get through the incumbent security mail gateway systems readily. There's a bunch of techniques that they use to do that, which we've gone into in a few other of these, like things like zero font and embedding things that confuse the pattern matching of the security mail gateways. But the point is, these are just very difficult to detect because they're coming from legitimate accounts. They're just accounts being used by someone illegitimately. The account itself is real. And again, there may be other signals here, like, for example, those PDFs, those might be malware, in which case this would be convicted just on the basis of that. But we do see a lot of these where really the only way to identify an account takeover is to use these kind of stylometric indicators, and again, use this large-scale clustering approach. So in conclusion, I think there are two really important takeaways here. One is to think about account takeover not just as a generic topic, but to think about whose account are you protecting. If it's your own employees' accounts, then don't use a tool to figure that out after the fact. Use a tool to prevent the accounts from getting taken over in the first place. And the primary tool for doing this is multi-factor authentication. You can absolutely prevent your accounts from being taken over using multi-factor authentication, and it doesn't place much of a burden on users. It's really easy to use one of these authenticator apps. So you should mandate, certainly for email, but also for cloud services in general, you should mandate the use of multi-factor authentication. And then secondly, to protect yourself from other people's account takeovers, in other words, their email accounts being taken over because they didn't do the right thing and they used multi-factor auth, and now their accounts are being used to target your users. That's where you can use a solution like INKY that's able to profile the mail that comes from senders and have some sense, almost like an intuitive human sense, but using math, like as I described, of is this new mail that's come in claiming to be from this user, is it similar to anything that person sent before? Just like we might say, well, is this play written like something Shakespeare would write? And hopefully you got a sense, there's obviously a tremendous amount of detail in doing these things. There's a long tail of, what are the features, figuring them out, how do you implement this stuff? It's complicated, but I wanted to give you some intuition. The concepts here are not that hard. The basic idea is, again, if you can figure out things that you can measure from the text, you can establish a distance metric that basically tells you, well, how close are these two messages to each other? Just like you could say, well, how similar are these two plays supposedly written by Shakespeare? Or how similar are these two Federalist Papers to each other? We know one was written by John Adams, so the other one, if it's very similar stylistically or stylometrically, it's probably written by him too. You can imagine it's the same thing here, and this lets us find, with great accuracy, these third-party account takeover emails, and either block them completely or at least give end users some sort of a heads up that, hey, this may not be the person you think it is. So hopefully that was helpful and useful and a little bit fun. We'll be back with another Phish Friday soon. But until then, I hope everyone has a great weekend and everyone stays safe. Thank you.